Okay, when the denominators are different and they're composed of polynomials, you have to look for common factors still for the two denominators before you try to put them together. So each of these denominators is composed of a single factor, x plus 4, and that's a linear expression. It can't be factored any further. Same thing with this one, x plus 6 is a linear factor, cannot be factored any further. So that means that since each of these have only one factor and they're not the same, the least common denominator for these would just be the product of the two denominators that are there. So I'm going to write that out long ways there. The first denominator is going to become x plus 4, x plus 6, the product of the two that were there. Then I'm going to write that minus sign, and I'm going to do the same for the second one. So the second denominator also has to become x plus 4, x plus 6, so that way they'll be the same. Now again, anything I do to the denominator to change it, I have to do the same thing to the numerator. So I'm going to go ahead and write down the numerators that were there in parentheses. And then I'm going to go back and figure out what I had to multiply by the first denominator in order to get my new common denominator there. So to to turn an x plus 4 into an x plus 4 times x plus 6, I had to multiply by x plus 6. So that means I have to multiply the numerator here by x plus 6 as well. So you'll notice if you're just looking at this first one here, there's an x plus 6 in common with the top and the bottom. So if you were to cross those out, that first rational expression would be identical to the first rational expression from the original problem. So that's kind of proof that we didn't change it. We just kind of changed the way it looked. Looking at my second denominator now, to turn an x plus 6 into this common denominator, x plus 4, x plus 6, we had to multiply by x plus 4. So I'm going to do the same to the numerator on that one, multiplying by x plus 4. And once again, just looking at the second one here, the x plus 4s, if I was just trying to simplify that one, the x plus 4s would cancel, and the resulting rational expression would be the same as the original second rational expression from the original problem. So again, didn't really change the value, we just changed the way it looked. All right, now that the denominators are the same, I can do what it tells me to do with the numerators. So I'm going to turn this into one big fraction now, writing down that common denominator, as the denominator just stays the same. And then I'm going to write out the numerators. So 3 times x plus 6 minus 1 times x plus 4. And now I'll simplify each of those little pieces there. So this 3 has to get distributed. So that would be 3x plus 18. And the second one, I'm distributing a negative 1 to each of those. So that would be a minus 1x, or just minus x. And a negative 1 times 4 would be minus 4. And then the denominator, the common denominator, stays the same. So I'm just keeping it. Now finally, in the numerator, I can add my common terms. So I've got a 3x minus x. Those are alike. So 3x minus x would be 2x. Then I've got 18 minus 4. 18 minus 4 would be a positive 14, so I'm going to write plus 14. And then on the bottom, I have x plus 4, x plus 6. Okay, now, if this could be simplified, then I do need to simplify it. So I'm going to look at the numerator and see if it can be factored at all. The two terms that are there do have a common factor. That common factor is 2. So I'm going to write out the factored version of that expression. If I factor out a 2, the other factor would be x plus 7. I'm just recopying that common denominator. And now I'm looking for common factors that I can cross out between the numerator and the denominator. My factors in the numerator are just a 2 and an x plus 7. In the denominator, none of the factors there are 2, and none of the factors are x plus 7. So this is as simplified as it can be. That would be the result of that subtraction. Now you're going to try this one and answer the question on the Google form.